Hello students, good morning. In last class we have done about the hysteresis. I told you basic about the hysteresis, that is the loop telling about the loss of energy, that is the telling when we are taking any ferromagnetic sample inside the magnetic field, then it will get magnetized by the induction. Then the magnetizing field intensity is vary, but it does not vary linearly with the B. That permeability that will be not constant but vary. Then is the how this one is the vary, that we will make this with help of the graph. Then hysteresis loop is the graph between H and B, where H equal to magnetizing field intensity and B equal to, that is the magnetic induction. That means when we will take a ferromagnetic substance inside the magnetic field, as we remove this magnetic field surrounding their material, then it also get magnetized after removing, that it will retain the property of the magnetic field due to the induction method. That's why this one is the graph between B and H is not linearly. Now how this one vary, we will make this graph. Here we are making the loop for magnetic induction and H. As we will keep the material inside this one, here this one material we are keeping inside the magnetic field, here we are taking magnetic field, then it will get the magnetized. As we remove this from magnetic field, then it also will be remain magnetized, it will retain the property like this one. How this one retain property? As linearly intensity will increase, then magnetic field also increase like this one. From O point we are starting, then point O representing initially unmagnetizing. This O is a initial unmagnetized. Initial means that material is there, and this one is the unmagnetizing point. Unmagnetizing magnetic field, magnetizing O state. Here we can write there where O point represent unmagnetized state of ferromagnetic substance. As we will take at magnetizing field intensity, as we will increase, then it or attain a constant value like this one, it will attain a constant value like this one. Then magnetic induction saturate at a certain value at which H will be maximum like this one. Now if H will decrease to 0, as we will decrease to 0 like this one, we are decreasing to 0, B also will get decrease, then after this A point, that is the region is the saturation mode, that is the saturation. As we remove this, H gradually decrease to 0, then B decrease, then B will decrease like this direction, but along a new path this B. Now it will find that magnetic induction does not become 0. On this point we will find magnetic induction, that is B is not 0. Then after this one, magnetic field H when is again decreasing continuously, then H is 0 on this point, that is H is 0 on this point, and on this B is 0, gradually decreasing. Then as we will come on this point, then magnetic field will 0, then sample is not demagnetized even magnetic field is removed. From this point we can say that is the, as we remove this magnetic field intensity, then it also not demagnetized completely. Then magnetic induction OB, that magnetic induction OB, this one term is known as the OB term is known as the retentivity, that is the retentivity, and this is the magnetic field remain as we remove that intensity. Continuously we will decrease in the direction like this one, the value of the reverse magnetic as a, then as we remove this continuously, then this also will be decreased, then B also will be negative, then H will be 0 on this point, and this point, this term is known as the coercivity, OC point, here OC, that is known as the coercivity, that is the coercivity. This term is the coercivity, at which in the on this coercivity we can say that is become H value will be equal to 0 on this point, and again we will decrease, then after decreasing at some value as we will start increasing, that will be B will be start decreasing like this direction. Clear? Now this OB is the retentivity and OC is the coercivity. Clear? Now from this one we can write there, from this one we can write there, hysteresis is the phenomena of lagging of intensity. As intensity we are increasing, then magnetizing force will be decreasing. Intensity of magnetization behind the magnetic field is known as hysteresis. The phenomena of lagging of intensity of magnetization behind the magnetic field is known as the hysteresis. Next hour we have done the retentivity. What is retentivity? From this graph that OC is our OB, not OC, OB is our retentivity, and this one is our intensity of magnetization left when magnetizing forces reduce to 0. Next our coercivity. What is coercivity? The magnetizing force applied in reverse direction at which intensity of magnetization reduced to 0. That from figure we can say one time at on this P point, then B will be having some value and H will be 0 at on this point, then B will be 0, H having the some value. That is the different term of the related to the hysteresis, retentivity and coercivity. That area of this one, area of hysteresis is telling about the not area of hysteresis loop tells about the loss of energy. That is the tells about the loss of energy. Clear now? This our hysteresis. Next we will do our different type of the ferromagnetic substances, soft ferromagnetic and the hard ferromagnetic type of the ferromagnetic material. That is the soft ferromagnetic material, and second is the hard ferromagnetic material. Soft, we can say that as we remove this magnetizing field, then magnetization will disappear after removing the external field, in which the magnetization disappear on removal of external magnetic field. Like this one, their area of this hysteresis loop inside this one will be less, like this. This one is a soft iron, and here will be hard, that as we will take their magnetic field, as we will keep their material, hard material, ferromagnetic material, then magnetization also retain after removing the external field, in which retain magnetization even after removal of external magnetic field. That we can say there is the, if we are making their loop, then loop will be like this one, then area of this will be large, like this. There is a difference between the type of the ferromagnetic material according to the hysteresis loop: soft ferromagnetic, hard ferromagnetic. Next topic we will do tomorrow.